Now, in talking about triangles, um, we've got to remember the different types of triangles that we have from our Year 7 days because we're going to get problems that start to talk about different types of triangles. These ones' definitions are pretty well known. But just to remind ourselves, and remember, a triangle can be defined as a polygon with three sides. And we classify it either according to sides or angles. So, in terms of sides, scalene, all three sides are different. Isosceles has two equal sides, and an equilateral has three equal sides. Um, that comes along with these two come along with ideas that, well, if those two sides are equal, angles opposite equal sides are equal. So that works the same here when we know all three angles are 360 degrees because it's a regular polygon as such. Acute angled means that all three angles there are less than 90 degrees because that's what an acute angle is. An obtuse angled triangle has one angle that is greater than 180 degrees, and a right angle triangle obviously has a right angle in there. So, and that's only going to have one in Euclidean geometry. We don't need to remember this formula, this proof. We don't have to remember the proof, but we need to remember this theorem in that the angle sum of a triangle is 180 degrees, and we've already talked about that with our polygons, and you know that from year 7 and 8. But there's the proof. So you get the three angles there. You know that you can form corresponding and alternate angles with these ones. We know along a straight line we get 180 degrees. So that's how we get our proof. The other one is what we call the exterior angle theorem. This is one that's not used very much, but when it's used when people need it in a proof, they often go and prove it. But the idea is that in any triangle, the exterior angle, so one that's been produced when the side of a triangle is extended, this angle here is equal to the opposite interior angles. And it's a pretty easy proof because these two add with x add up to 180 degrees, and w plus x equals 180 degrees. So that means those two angles must be equal to this angle there. That's our proof for it, just using the supplementary angles and angle sum of a triangle. So, but a lot of people just go and prove that and use it as they go. It can save you some time and effort if you remember just to quote the exterior angle theorem there. So, looking at a question that involves this idea, so if we've got to find x here, we've got 3857. Well, we know we're going to get a corresponding angle of 57 in there, and then these two angles must add up to x because for the exterior angle of a triangle theorem, which means it would be equal to 95. A lot of times people would get that angle, then corresponding angles get that one, and then they're supplementary. It's a little bit more work. This way is much more elegant. Not necessarily wrong to do the other way, and because it will get you the right answer, but try and do it the most efficient methods possible.